Good morning. In this lecture, we are going to basic elements present in electrical circuits. The basic elements are classified into two types. The first one is active elements and the next one is a passive element. Now, what are active elements? The active elements are the elements which are able to supply electrical energy. If you see, the example for an active element is battery. Battery is a device which generally supplies electrical energy to the other equipment. So we can call that one as an active element. Any device that can be able to provide electrical energy or a power to other equipment is called as an active device. Moving on to the passive elements. Passive element is an element which consumes electrical energy, convert it into other form. Example for passive elements is a resistor, inductor and a capacitor. Inductor is represented by L, whereas a resistor with a R and capacitor with a C, with a capital C. If you consider resistor consumes electrical energy and convert that electrical energy to heat energy, whereas inductor consumes electrical energy and convert that electrical energy to magnetic field, whereas a capacitor converts that electrical energy into electrical field. So in conclusion, the elements which are RLC, which consumes electrical energy, are called as passive elements. Example for these passive elements are resistor, inductor and a capacitor. First we are going to discuss each and every passive elements, then we are going to move on to the active elements. In a passive element, the first one is resistor. Resistance is the obstruction possessed by the conductor. Take a conductor. When you try to move the charge carriers from one end to the other end, these charge carriers will experience some opposing force. This opposing force is due to the resistance of the conducting material. Generally, this resistance is due to the collision of charge carriers with the ions or atoms inside this conducting material. Due to this collision, the current intensity will get reduced. So this property is called as resistance or resistivity. So if I increase the length of the conductor and perform the same experiment, the resistance will be more. So we can conclude that resistance is directly proportional to the length of the material. And if we perform the same experiment for a thicker conductor, and we can observe that as there are multiple paths for these charge carriers to flow from one end to the other end, the resistance will be less for larger cross-sectional area. So we can say resistance is inversely proportional to the cross-sectional area. So in conclusion, the resistance equation R equal to rho L by A, where rho is a proportionality constant which is specific resistivity of a conducting material, and L is the length of the conductor, A is the cross-sectional area of the conductor. Both length and area should be in SI units, which is meters and meter square. One more point to note here is rho, which is a specific resistivity, does not depends upon the length of the material or cross-sectional area of the material. It simply depends upon the type of the material, whereas resistance depends upon the length of the material, depends upon the cross section of the material, as well as it depends upon the type of the material. This is resistivity, this is resistance. and the units of a resistance is ohms, represented with this symbol. Moving on to the next element, inductor. Inductor has a property called inductance. Now what is an inductor? Inductor is nothing but a conducting material which is as a coil, wound as a coil, wound as a coil in this way. In this way. Let's suppose say a current I is flowing in this conducting material. As you studied in an intermediate, a current carrying conductor has flux around it. This flux, this direction of flux is represented by right hand grip rule. If you observe, this is the direction of a current. To apply a right hand grip rule, you have to place your thumb in the direction of a current and the four fingers represents the direction of flux. If you apply right hand grip rule, the flux at this particular point it will be in this way, whereas at this particular point the thumb the thumb will be out of the board, and if you apply a right hand grip rule at this particular point, the flux direction will be in this particular way, which is anti-clockwise direction if you see on a 2D paper. Similarly, below that one it will also in a anti-clockwise direction, and over here it will be a clockwise direction, over here it will be clockwise direction. So in conclusion, for this type of a winding carrying a current I, this inductor is producing a flux in this direction. If you add all these fluxes, they will be in one direction, which will be upwards, leaving from this end and completing a loop by entering the other end. So in conclusion, we can say inductor converts electrical energy to magnetic energy and stores this magnetic energy. Whereas coming to the capacitor, the construction of a capacitor is simpler than the inductor. There will be two plates are generally connected to the voltage source, as positive side of the battery is connected to the upper plate. This positive plate repels the positive charge carriers. These repelled positive charge carriers will get accumulated over here onto the upper plate. Similarly, the negative terminal of the battery is connected to the bottom plate of the capacitor. As this is a negative terminal, this will repel the electrons or negative charge carriers, and more number of electrons are accumulated over here. Due to the accumulation of these electrons, an electric field from positive to negative is created between these two plates. So in conclusion, we can say capacitor is a device which converts electrical energy into the other form, and it stores the energy in the form of electric field. Moving on to the amount of energy stored in an inductor and as well as a capacitor. For an inductor, we saw the electrical energy which is delivered to the inductor is stored in the form of magnetic field. The expression for the energy stored in an inductor is given by EL equal to half Li square, where E is the energy stored in an inductor, L is the inductance value of the inductor, and I is the current carrying by the inductor. Similarly, for the capacitor, the energy stored in the capacitor, the expression for the energy stored in the capacitor is given by E suffix C equal to half CV square. half CV square, where EC is the energy stored in the capacitor, C is the capacitance value, and V is the voltage across the capacitor. And one more property that an inductor and capacitor have is that inductor opposes a rapid change in current, whereas a capacitor opposes a rapid change in voltages. The reason for this one is the current is directly proportional to the flux. As we try to change the applied current, already existing flux will oppose that change in current. Whereas in a capacitor, the voltage is reason for the electric field oppose any variation in voltage. This property is most important one, as based on this property many applications came into picture. Moving on to the next classification, which is active elements. In active elements, the active elements are classified into two types: independent sources, dependent sources. Independent sources are the sources which does not depends upon any other parameter. If a particular voltage, suppose say, if a particular voltage source is supposed to deliver 3 volts, it should deliver 3 volts. It should not depends upon other parameters like what is the voltage in the other branch, what is the current in the other branch. It simply has to deliver the rated voltage. Whereas for the current source, if a particular current source is supposed to deliver, let's say 10 amps, it should deliver 10 amps at all time. In independent sources, we generally have a voltage source and a current source. Ideally, the voltage source will deliver the rated voltage and current source delivers the rated current. But practically, this is not possible because of internal resistance present in the voltage source. The voltage source may deliver a little lesser value than the rated value. This is due to the voltage drop at this particular resistor. This drop will become more noticeable for higher currents. If the current is high in the resistor, then voltage drop is nothing but I into R. If a current is high, voltage drop V will be high. If a voltage drop is high, the potential difference across these two terminals will not be there as it supposed to be. Similarly, for the current source, it should deliver the rated current. Let's suppose say it is delivering at 10 amps, but due to some leakage current, this leakage current is represented by a shunt resistor. Instead of delivering 10 amps, it will deliver a current lesser than the 10 amps. Moving on to the next classification in active elements, which is dependent sources. Dependent sources are classified into four types. The representation of a dependent source will be in this shape. If it is a voltage source, it is represented with a plus and minus symbol. If it is a current source, it is represented with the arrow. It is represented with the arrow. Generally, dependent sources depends on other parameters in the circuit, such as current and voltage. Let's suppose say we have a dependent voltage source. If this dependent voltage source is depending upon other parameter, which is voltage or current, then we can call this one as a dependent voltage source. If it depends upon the voltage, then it is called as a voltage dependent voltage source. If it depends upon the current, then it is called as a current dependent voltage source. Similarly, for the current source, if a particular current, the amount of current that need to be generated by this particular current source depends upon other parameters such as voltage in adjacent branch or current in some other branch, then that type of voltage source is called as a current dependent current source. If this current source depends upon the voltage, then it is called as a voltage controlled current source or voltage dependent current source. If it depends upon the current, then it is called as current controlled current source.